Okay, good morning everyone. Thank you, Misha, for opening the summer school. And also many thanks from NORMA for the organization, particularly to Vasilis, then as well as Marcus, who did a great job in organizing the event. My name is Rost. I'm actually the project manager of NORMA, and I have now the pleasure to introduce you to NORMA as well as the summer school as a whole, including the agenda. And as soon as you're going to see my picture, I can continue. Yeah, it's old school, you know, it's still VGA. Oh yeah, cool. Thank you very much. Okay, so again, good morning. Actually, Misha has said already a lot. So NORMA is a European collaborative project funded by the European Union. Hopefully, we continue to have those meetings in the UK in the future. There's many operators, vendors, universities, research institutes are actually jointly investigating a 5G architecture. And now, hopefully, some of you are already asking yourself, what is actually 5G architecture? And then why the heck do we actually need it? Because we have a very successful 4G architecture, a very successful LTE system right now in place. And why would you ever need it? And the answer is actually in the past. So it actually started in the 70s or 80s with analog systems, with first generation systems. And then GSM brought in digitalization and mobile communications. And since then we're actually still in the digital domain, but the usage of our phones changed significantly from voice calls at the very beginning. We are now playing games on our mobiles, we're downloading videos. So actually the usage changed significantly. And every time when we change the system and the usage of the system, actually also the architecture changed significantly. Particularly if you compare third generation systems or CDMA, the fourth generation LTE, they actually got a very flat architecture. There are lots of functionality you can actually push towards the edge of the network. And every time that we introduce a new architecture, this actually also means for operators that they need to deploy a new network. Right? So they have to buy new equipment, they have to change the system. And this costs a whole lot of money, it costs a whole lot of time and a lot of testing. So it's a very tedious process. And one of the main objectives of NORMA is now to introduce a new architecture, a fifth generation architecture, that is future-proof. So this is kind of the umbrella of the whole project, future-proofness. Whatever happens in the future, our architecture shall support it. And not only to you, but also to me, this sounds a little bit like crystal ball reading. Yeah? So because we cannot really predict the future. And in order to actually accommodate all the future services, we actually have to support a very, very heterogeneous mix of services, ranging from gaming, tactile internet, video streaming, voice calls, of course, towards on the other edge of the extreme IoT services, where you only have one packet once a day, for instance. And all of this needs to be delivered through or shall be delivered through the same network, through the same system. And you can guess this is very difficult to do it with one and the same system, like with LTE. Although LTE is really a brilliant system, extremely well engineered, there are still some flaws in there where you have, I would call them bug fixes right now, and where you need to get in and have new mechanisms within our system also to support this heterogeneous mix. And one of the answers to this question, or one of these enablers to support this heterogeneous mix, is actually network slicing, which was brought up last year by a 5G white paper by the NGMN Alliance. And now all of you who already heard this buzzword slicing in the past, I think the immediate question is then, okay, what is slicing? Yeah, so we are not even that close at this stage where we can talk about slicing without talking about what it really is. Yeah, so kind of this very basic definitions. For us in the project, and I think that we have a consensus also with all the other 5G projects, it's supporting a large set, medium-sized set of end-to-end logical networks on top of the same infrastructure. Let it be virtualized or non-virtualized, doesn't really matter at the moment, but it's many end-to-end logical networks on top of the same physical architecture or physical infrastructure. And there it starts to become really, really difficult, because how could you actually have many different networks and still the same base station? Yeah? So you have an IoT provider who reads your smart meter at home, you have your gaming, you have maybe Telefonica providing you connectivity, and everything at the same base station. And the base station still has to discriminate the service. Right? And in order to support that, actually, we came up with 5 very, very basic innovations that we want to introduce with 5G NORMA, and that must be supported by the architecture that is derived. And the first is, I will put in the right order, so the adaptive function placement and decomposition. That means we take the set of all functions that are necessary to operate a mobile network, then we decompose the set of functions, and only take those functions that are really necessary to operate a certain slice. Okay? Then we optimize these functions so we can actually replace them, then we put them into a network slice and operate this network slice. That's basically how this flexible composition and decomposition is supposed to work in the future. Then we have this co-optimization of LAN and core network. That means there are certain functions that are currently located in the core network that we think shall be pushed closer to the edge in order to co-optimize with radio access network functions. Right now there is actually no decision at all, or no conclusion at all, at what granularity this happens. Yeah? I mean, one of the possible conclusions may be that we just say shift the whole MME, or shift the whole control plane towards the edge, or control plane plus user plane. So there are many, many different options that we're currently investigating, and actually tomorrow there is a talk by Christian Mannweiler on the 5G NORMA architecture, and he will definitely shed a little more light on this topic. The third one is the software-defined mobile network control and orchestration, and that means if you decompose your mobile network in many, many different functions, then someone has to decide which functions you are using, where are they placed, how do I parameterize them, and also to control them and monitoring these functions. Okay? And this is basically put together in the framework of STMC that we are investigating in 5G NORMA. And on this topic, actually, Albert Banks is going to say much more on Wednesday in the early morning. We have very, very recent results on this topic. And then we have these ideas of multi-service and context-aware adaptation, as well as multi-tenancy. By multi-tenancy is very much going to this direction of network slicing. To show you a couple of results or a couple of illustrations that we already had in the project. So this is actually the current draft architecture that we derived with 5G NORMA. Looks very complicated, but once Christian explained it, I think it's much clearer how it works. And the basic idea is kind of the conclusion from this slide should be 5G NORMA is not only working in the typical networking domain, so you're not only looking at the networking functions like the scheduler, like the forward error correction or the MME, but we are also looking on the management and orchestration layer. So what is really needed to instantiate a slice on demand, although on demand doesn't mean within seconds, but it's a larger time scale of course. As well as up there the service layer. So who's actually using then these slices, and if a slice is actually covering multiple infrastructures. So if you think of your base stations may be operated by someone else than your backhaul network, for instance, then you need some mechanisms to actually allow for interworking of these different domains. And this is everything covered in this management orchestration layer as well as service layer. Now, if we go a little deeper into the networking layer, we have this flexible function allocation as mentioned. There are 3 examples. The first one is vehicular communications, where you would rather put all your functionality towards the edge because you need very, very low latency, very short response times. And then it's actually better to also push all your functionality towards the base station, right? While if you think of mobile broadband, that's really about massive processing of data. Yeah? There it's probably better to use multiplexing effects and rather push your functions towards cloud hardware, for instance, or a more centralized entity. As mentioned before, if you have all these functions, if you have these many different deployment options, actually your architecture becomes very difficult, let's say, to understand, and even more difficult to display or to draw it down. That's why actually we in 5G NORMA have many different views, or 4 different views to look on the architecture, and those are shown on the right-hand side. That's the deployment view, the topological view, the resource view, and functional view. And all these different views are actually then explained in more detail during the summer school, so till Wednesday. I have to jump back. And as mentioned before, a central element is the software-defined mobile network control. Here is a short example that actually, if you have different users within the network, like vehicular users, mobile broadband users, then actually you can parameterize your scheduler based on the usage behavior, or based on the behavior of these different users. I'm now a little rushing because we have to go through the next presentation. Now in 5G NORMA, we actually have many different demo activities, overall 6. The first one is actually an illustration of what actually happens if you start pushing your functionality towards the edge using a tactile controlled car. So we have an iPad, and with this iPad you can control your car, and then there are different modis where you have functions differently allocated within the network, and based on the allocation, actually the latency changes, and then you can see how the response time to the car control is actually changing. The second example is different parameterization of headnet schedulers. So it's done by NORMA. It's an emulator where you can actually differently parameterize the scheduling. You can actually place the scheduling function at different places within the network, so more centralized, more decentralized, and then observe how the data rates in the network are actually affected. We have a very detailed example of a Mano instantiation using existing projects like Open Daylight. We have one demo where a full-fledged SDN network is actually implemented and complemented with SDMC capabilities, and there we have a couple of radio access points, and then you're controlling these radio access points in a software-defined manner. That's actually done by the University of Madrid. And Albert, if you have more questions on that, just check with him. Then we have this virtual AAA instantiation done here at KCL and Stan's team. So address them if it is of interest to you. And I think one of the really cool highlights of 5G NORMA is the Capiche tool implemented by Real Wireless. And this is going to be an online tool where you're able to have a techno-economic analysis of the network. So you can actually enter the network size, base station density, usage behavior, and so forth. And then you just put a button, and then you get a techno-economic analysis. So kind of how much margin you actually get in the end for a certain deployment. Okay. All right. So much about 5G NORMA. What is actually the objective, or what are the objectives of the summer school? As you could actually tell from the agenda that hopefully all of you got, so this nice little leaflet with all the talks that you can hear till Wednesday. They have a good mix, I think, of industrial leaders as well as academic leaders. And I think in the audience, I think we have both industry guys, academic guys, we have grad students, postdocs, which I think is a good mix, and it gives us a good opportunity to discuss certain topics, to prove you that even architecture topics can be very sexy and a good topic for a PhD thesis. And we of course want to share our recent results from a 5G NORMA perspective. But we also have other projects like tomorrow morning, we have Michael Meyer from ATIS2 giving a presentation in the data plane session. So there are also other projects being presented here, and I think we're going to have a good discussion also between different projects. Okay. Agenda-wise, today I think is really a lot of highlights. So we actually have Mike Short from Telefonica is here giving a presentation. Jonathan Hart. We have Simone Regana, who is not yet here. Okay, so hopefully didn't take the wrong metro. And we have two so Ali Hosseini and Linus Tibon. Hopefully spell him correctly, or pronounce it correctly. Giving a very interesting view also on vertical industries, because 5G is also not only, but also tackling to a large extent vertical industries like automotive, smart factories, or in the case where what Linus will tell us, wind parks, for instance, where actually 5G communication is going to play an important role. Okay. Then we have 2 panels in the afternoon, and tomorrow as well as on Wednesday we are going to have a couple of sessions on architecture, on data plane, control plane, softwareization, network virtualization. So it's, I think, a very diverse mix, which will hopefully shed some light on the topic. Okay, some logistics for you. There's an open Wi-Fi that you can use if you're from universities. You have EduRoam, so I think we use it in eSpite. For all the other guys, there's the cloud. Just connect to it, register, and then everything should work well. Lunch is more or less all around KCL, so there are many little bars, cafes where you can grab a short bite. Hopefully you don't get too wet, but it seems to still rain. And then actually Micha already said there's a video recording, so all sessions are video recorded. If you prefer that your material is not put online, let it be your PowerPoint slides as well as the recording, tell us, and it's not going to be put online. Otherwise, we assume for the moment a silent approval. That means it's going to be placed online. Now, actually, the first talk would have been in your leaflet is still Bena Bahani, who unfortunately was not able to make it. Actually, he had some travel problems. Now Simone Redana took over the slot. He's going to speak out from more European, so practically European point of view. But apparently his flight was also late. Now, I don't know, is it okay if we start with you? Yeah. Perfect. Then actually it's a huge honor, really very great, Mike Short, to have him here from Telefonica, to give a presentation on 5G towards 2025. So please welcome together with me Mike Short.